Tezos is an extremely underutilized blockchain and has a ton of room for growth. With incredibly low gas fees, this space is perfect for making NFTs, dApps, and even games on the Tezos chain. I've noticed that there's next to no resources on YouTube right now showing how to set up a Tezos development environment, so that's what we're going to do in this video. I'm going to walk through the steps for spinning up a local Tezos Sandbox chain, setting up a Tezos command line interface client to communicate with it, and then also deploy a smart contract written in LIGO to that sandbox. Prerequisites for this video are just basic programming knowledge. You don't need to know a ton, but basically just enough to drive a computer. And then you're also going to need to have Docker installed on your computer. So the first thing that we're going to do is we're going to set up a local development environment. You don't have to run things locally. You can push things just straight to a testnet or something, but I just prefer to run everything on my computer. It just makes things quicker and easier before I deploy anywhere. Tezos offers a Docker container that you can run. If you don't have Docker installed, there's a link in the description in this video. Just pause the video, go get that set up and come back. Assuming you've got Docker set up, just Google Tezos docs. It's gonna be one of the first results. I've got it right here. It takes you to this Tezos developer portal website. And this site has a bunch of useful information, some tutorials, some links to libraries that are popular in the Tezos community, and a bunch of other stuff. But the thing that we're interested in is this Learn tab here. There's a Getting Started button, and there's a link to this Spin Up a Sandbox link. This is pretty much everything that we need to get the development server set up. Before you can use the Sandbox, these docs are saying that you need to get a Tezos Client. It's just like a CLI tool so you can interact with the blockchain through your terminal. If you have a Mac like I do, just run these brew commands and it'll install the Tezos Client for you. There's nothing else you need to do. If you have Linux or Windows, there's also instructions for that, but I got a Mac, so this is what I did. Once you run those commands, you should be able to just do Tezos Client -- version, and it should spit out some information indicating that you've got it set up correctly. Now that we've got that Tezos Client set up, we can move on to the next step, which is getting the Sandbox running. The Sandbox is this is the Docker container that I was talking about earlier. It's developed by this team called Flextesa. If you want to look more in-depthly, they've got a GitLab page where you can look at how this thing is kind of working under the hood. But for our purposes, all that we're really concerned about is this command right here, docker run. And it just spins up this spins up a Docker container using this image that they develop. So just copy that and paste it into my terminal, and it should set up a Sandbox server. So if I run docker ps, yep, it's right there, my Sandbox. It's running on port 20,000. We've got a container running that has a local Sandbox blockchain that we can interact with. So let's interact with it. In order to do that, we need to set our Tezos client to use this localhost server as the RPC to communicate with. So if we just copy this command, Tezos client -- endpoint HTTP localhost 20,000 bootstrap, it'll set that up. It'll spit out this warning saying that we're not on mainnet, which is good because we're not. And then also run this config update to do basically the exact same thing. Now, we need some wallets. Fortunately, this Sandbox server actually already has some Tezos wallets baked into it. So if you copy this Docker command, it'll get you some info on the currently running container. Docker run -srm tq tezos /flextesa grandbox info. It'll spit out some information on some wallets that we already have access to, Alice and Bob. These are their public key hashes, public keys, and then their secret key. So we just need to grab the secret key and then add it to our Tezos Client list of known addresses, and then we should be able to get information from our locally running Sandbox. That command is down here. Tezos Client import secret key Alice, and then that secret key from this list right here, --force Tezos Client import secret key Alice, paste it, --force. And then it says that we added the address. So now we are pointed at the local Sandbox. We've imported an address. We should be able to get the balance of this address now. So Tezos Client get balance for Alice. Boom. We got 2 million Tezos to play with. We've got the Sandbox server running. We've got the Tezos Client set up, and we've imported the wallet to use while pointed at the Sandbox server. The next thing we need to do is actually deploy a smart contract to the Sandbox and interact with it. Tezos has a couple different options for writing smart contracts in terms of languages that ultimately get compiled down to Michelson, which is then deployed to the blockchain. For this tutorial, I'm going to be showing you how to use LIGO. Another option, if you prefer something like Python, there's SmartPy, which is a Tezos contract library for Python. But here I'm just going to show you how to use LIGO. LIGO, in order to use it, you got to go to their docs site, ligolang.org. There will be a link in the description. And grab this docker run command. If you run that, it'll say this LigoLang compiler missing subcommand for command LIGO. That basically just means that this command right here is actually the Lingo language itself. Like, this is how you run LIGO scripts. You run this docker run and then whatever the LIGO script you want it to interpret is. So if I go like version, you can see that this is running version 0.3.4. Excuse me, 0.34.0. So what I did is alias this docker command, so I can just run it by running just the word LIGO. So I did alias LIGO equals, and then just this command right here. And now I can do LIGO version. That way it's just makes it easier to type things out, so I don't have to type out this entire thing every time I want to run a LIGO script. Next, let's just grab a smart contract from here. So from their tutorials section, I think that there's one. Yeah, right here. Just grab this quick little counter. So basically, I mean, what this is doing, this is the main function right here, and you have the option of either incrementing or decrementing the storage, and it also has a reset function. So if we compile this down, we should be able to just turn this into a contract that we can deploy on our Sandbox and then interact with using our Tezos client. All right, let's write this on our computer. It looks like they're naming it increment.mligo. So let's do that ourselves. Make directory, call it tz test. Touch increment.mligo. And then open up a text editor. I use VS Code. I mean, anything will work. I've got a link in the description if you want to use the same thing as what I'm using. They do have an extension for LIGO in here. I've got it installed right now. It's got a few, it's not super great, but it does at least light up the correct syntax and stuff, you know. So let's copy this code into this file that we made. And then I should be able to compile this contract using the LIGO command. So what this line of code is saying is that that Docker container that we have, that LIGO, the one that runs LIGO scripts, has a command in it called compile, and then that compile command has another command in it called contract, which takes an argument of a mligo file. So it's going to compile this mligo file and take the output and put it into a file called increment.tz. So I'm going to copy that into the terminal window here in VS Code, and then hit enter, and it should generate an increment.tz file, which it did. And this is all that you need to do in order to compile a smart contract. Like, this is a smart contract right here. All we got to do is just deploy this to a blockchain and you can interact with it. Let's deploy it to our local blockchain. Let's see. So there's a bunch of things you can do with this tutorial. It goes over testing a contract. That LIGO script has this run interpret add, which is basically what it's doing is it's looking at this function here and just verifying that this is working as you'd expect it to. And then you can also test you can write tests for LIGO right in the LIGO file itself. Like, you just copy, if you just copy this and put it in increment.mligo, LIGO's smart enough to know that this is a test, and it will run this test and hopefully successfully. So if we do this, yeah, see? Test exited with value true. But we're not super interested in that. I mean, testing the Michelson contract. So rather than testing just the LIGO script, you can also go straight into the written contract and test it that way. What we're looking for is down here, publishing the contract. So we can put this on the blockchain right now as it is. So this Tezos Client CLI has a command called originate contract, and you pass it the name of the contract that you would like it to be aliased as. So we're going to originate a contract, and then locally we can call it by calling increment. And then the next line says that it is transferring 0 from Alice. Alice, if you'll remember, is the alias of the testing wallet that we added to our Tezos Client config earlier. So Alice will be deploying this contract, and Alice will be sending 0 Tez into the contract when it's originated. And then it is going to run this Michelson code that we generated using the LIGO create or compile contract script, increment.tz, and then setting the initial value to 10 and the burn cap to 0.1. The init value varies, it just depends on what you got set up for the contract storage. What this specific contract is doing is starting with a initial value for storage, and then you can pass it integers as to either increment or decrement from that initial value. So it just means that it'll start at 10, and if we increment it by something, it will be 10 plus whatever we pass it. But anyways, we should be able to just deploy this. So let's go into our terminal, paste our command in here, and then run it. And look at that. It created the contract. Beautiful. So it tells a bunch of information, talks about the gas fee and all that fun stuff. Ultimately, what we're interested in is this originated contract address, but we actually don't even need that because we gave it an alias previously. We called it increment, so we should be able to call this increment contract via the Tezos client. And back in the tutorial doc, it has a command here, Tezos client call increment from Alice. So the Alice wallet is calling our increment contract, and we're passing in the argument of left, right, 32, which is just Michelson code for we're gonna call the increment, the increment function that we have deployed. So if that worked correctly, since the initial storage was 10, we should get an incremented storage of 42. Boom, look at that. So we got a deployed contract. And that's where I'm gonna end this. The next step would probably be to put this on a test net or on the main net, but the process is actually pretty similar. But you just, instead of setting the Tezos client to look at the localhost server, you just point it at a different RPC and just use an address that, or use a wallet that is on that chain, and it just works. That's pretty much everything there is to it. I hope you found this helpful. Let me know in the comments if you'd like me to make another video or keep doing this kind of thing. I've got a couple more ideas of videos that might be helpful for people developing in Tezos. Deploying a contract to an actual Tezos node, making contracts for tokens like NFTs and stuff. That's just a couple of ideas that I had. Let me know what you think. Thanks. See you later.